Okay, this is quarterfinal, the practice quarterfinal, question 5. This is the application part. We got long triangle, but what's scary about this one is that you got 3 big unknowns, x, y, and z. There's so much to do, but how do you break this down? Clearly, if they're asking you so many questions, why not just simplify it and just draw it out differently? So if I have x, y, and z, just focus on one of them at a time. So I'm just gonna draw a small triangle, just writing what I know. So I know that the degree is 20, and I know that the hypotenuse is 16. And I just put x. I don't need to include y, I don't need to include z. What does that do? Well, that allows us to figure out how to solve for x. Again, how do you solve for x? This is where you use trigonometry, where you identify SOHCAHTOA. So again, I have to ask myself, what do I have? Well, I said for 16, that's h. X is next to 20 degrees, so we call that a. I have a and h, so I'm definitely using this one, cosine. So I'm gonna write cosine 20 equals a over h, x over 16. If I want to solve for x, this is what I do. I like to make cosine over 1. Why? It's because whenever I see two fractions, I cross multiply. 1 times x, that gives me 1x, and then 16 times cosine of 20 would be my final answer. So all I need to do is simply put this into my calculator. So if I just put it, it would be 16 cosine 20. That gives me my answer of 15.04. That's part A, or at least for x. If I want to solve for y, what am I going to do? Again, you don't have to use any other information except for what you know. I'm going to draw one small triangle again, having 16, having 20, and having y, and doing the same thing again. Labeling h. This time y is not my adjacent side. It's not a. It's away from the angle, so we call it O. O and h makes this time sine. So I'm going to write sine 20 equals y over 16. I do the same steps again. Make it over 1, cross multiply. So 1y equals sine 16 sine of 20. I put that in my calculator and I get the following. So I'm going to put 16 sine of 20, giving me 5.47. Then the last part is part Z, I guess. Part Z is a little bit different. If you can tell in the beginning problem, Z is the inside of the triangle. It's not talking about any side length, so technically I don't even need to do trigonometry. What am I going to do then? This is the idea of the angles in a triangle. If I have 20 here, 90 degrees here, and Z as my angle, here's what I need to do. I simply need to remember that if I add all these up, they make 180. What would that look like? I'm going to write Z plus 20, because that's one of my angles, plus this one, the square. What is the square? That's simply 90 degrees. I'm going to make it equal to 180 and solve for Z. 20 plus 90 gives me 110, so I write Z plus 110 equals to 180, and I need to get rid of 110. Opposite of addition is subtraction, and so all I have to do is subtract both sides. That gives me my answer that Z equals to 70. And that is our final answer for X, Y, and Z. So what looked like a daunting problem because there's so many parts really is just 3 simple things all combined into one. You want to find missing sides using trigonometry, while to find a missing angle, luckily you don't even need to use trig. Just remember that the sum of all angles in a triangle add up to 180. And that is the answer to the problem.